Welcome to this session. Again, we will solve few more important problems. Let's take a problem. A right triangle a right triangle whose sides are 3 centimeter and 4 centimeter is revolved about hypotenuse. Find the volume. Find the volume and surface area of the double cone so formed. So in this question, there is a right triangle. Say, let us take a right triangle. A, B, C having right angle at B. And say this side is 3 centimeter and this is 4 centimeter. Now let's solve it. Now first, by Pythagoras theorem, we can have AC square is equal to AB square plus BC square, which is nothing but 3 square plus 4 square, that is 9 plus 16 or 25. Or so AC will be root of 25, that is 5 centimeter. Now this triangle is revolved about the hypotenuse. This is the hypotenuse and it so generates a double cone. That means it is just revolved about this and we get two cone. One cone, this one, and another cone, this one. We have to find the volume and the surface area of this double cone. We know for volume we need the radius. Suppose let us join this line, call this as O. So we need this BO and also the height AO. We know AC is 5 centimeter. Now in order to calculate this radius, let me consider area of triangle ABC is half base. I am taking BC as base, half into BC into the height AB. This will be 1 by 2 times BC is 4 and 3, which gives you 6 centimeter square. This is the area of the triangle. And also we know area of same triangle ABC, considering AC as the base, will be half multiply by AC multiply by BO, and this area is the same, so will be equal to 6. This will imply that half AC we have as 5 and BO is equal to 6. This will give us BO is equal to 6 multiplied by 2 on 5, that is BO is 12 on 5. This is important information. Let us put it in a box. Now we got BO, which is nothing but the radius of cone. Now next I need the height AO. Now in right triangle ABO, I am considering ABO. This is also a right triangle. In this right triangle we have AO square will be equal to AB square minus BO square. This is again using Pythagoras theorem. Now this gives me AB is 3 square minus BO we have just now found out, which is 12 on 5 square. So this is 9 minus 144 on 25, which is 25 225 minus 144, which is equal to 81 upon 25. So AO is square root of 81 upon 25, which is 9 upon 5. We will put this also in a box, will be used further. So now we get AO as 9 upon 5. So CO is 5 minus AO, which is 5 minus 9 upon 5, and this is 25 minus 9 upon 5, or CO is equal to 16 upon 5. This also we will keep in box because this is the height of this cone and AO is the height of this cone. CO is the height of the lower cone and AO is the height of the upper cone. Now using this information we will calculate the volume and the surface area as asked. Now we know volume of double cone is equal to volume of upper cone plus lower cone. That is, the formula for volume is pi 1 by 3 pi r square h. Applying this formula, we will get 1 by 3 pi r of the upper cone, and radius we know is 12 on 5 square, and the height of the upper cone is AO, that is 9 on 5 plus 1 by 3 pi, again the radius is the same, 12 upon 5 square, but now the height of the lower cone is CO, which is 16 upon 5. Now 1 by 3 pi times 12 by 5 square is common. We will take this out. Pi 12 by 5 square common, and we are left with 9 by 5 plus 16 by 5. Further solving it, 1 by 3, let's take pi as 3.14. This squaring 144 upon 25, and solving this, 5 and 9 plus 16 is 25. 25 and 25 gets cancelled, and solving it, we will get 30.144 centimeter cube. This is the volume of the double cone. Now, surface area. Surface area of double cone. We know surface area. Curved surface area of a cone is pi r L, where L is slant height. Slant height. Now this will be the curved surface area of upper cone plus curved surface area of lower cone, which is pi r, that is 12 upon 5 L. For upper cone, the slant height is 3 plus pi, radius is same for both the cones, and for lower cone the slant height will be this 4. This is the slant for the lower cone. This is 4, and this, on solving, we will take pi times 12 on 5 common. We are left with 3 plus 4, and that is, putting the value of pi, 3.14 times 12 by 5 times 7, and on solving it, we will get 32.8 square centimeter. This is our final answer, which is the surface area of the double cone. Let us take another question quickly. A copper wire A copper wire 3 millimeter in diameter wounded about a cylinder whose height is 12 centimeter and the diameter is 10 centimeter, so as to cover its curved surface. Find the length and the mass of the wire, assuming the density of copper as 8.88 grams per cubic centimeter. This is very important question, and many a times it has been seen in examination. Let us solve it. There is a cylinder. Suppose, let us consider this is a cylinder of height 12 centimeter and its diameter is 10 centimeter, and a copper wire whose diameter is 3 millimeter is wounded around this way, this way, this way, simply to cover the entire curved surface. Now we know diameter of wire is 3 millimeter. That means 3 on 10 centimeters. So in one round, the wire covers 3 by 10 centimeter on the curve surface of cylinder. Now, so number of turns to cover 12 centimeter is equal to 12 divided by 3 by 10, which is 12 to 10 by 3. Cancelling, it gives you 40 turns. Now the length of wire in one turn is nothing but its circumference of cylinder, that is 2 pi r, or 2 into, let me take pi as 3.14, and the radius of the cylinder is 5 centimeter, and this will give this many centimeters. This is the length of the wire required for one round. So total length of wire for 40 turns will be 2 into 3.14 multiplied by 5 into 40, which on simplifying will give 1256 centimeter. So this is the total length of the wire that will be used. Now we have to find the mass. Mass of wire is volume times density. Now volume is pi r square h of wire times the density. So this is 3.14 into radius of the wire. This is the diameter. The radius of the wire is going to be 3 upon 20 square into height. Height is actually the length of the wire, that is 1256 centimeter. On simplifying, we get 788 grams. So this is the mass of the wire and the final answer. Thank you very much. We shall discuss few more problems in the next session. Have a nice day.